Okay, welcome to the webinar, Alarm System Auditing and Enforcement, the Why and the How. The audio for this webinar is through GoToWebinar. If you have questions along the way, please feel free to enter them into the question box, and we'll try and get to them at the end. I'll also probably collect them and actually answer them via follow-up email related to the webinar, and the link to go listen to it again if you enjoy it that much. So my name is Todd Stauffer. I'm the Director of Alarm Management here at exida. I've been involved with alarm management pretty heavily since the early 2000s when I first joined the ISA 18.2 committee and got pretty involved in that and helped write the first version of the ISA 18.2 standard. Then I got involved in creating some of the technical reports and the co-chair now for a new standard that we're writing on process safety, controls, alarms, and interlocks, bringing together the world of functional safety and alarm management. If this is your first exida webinar, welcome. If you don't know much about exida, we were founded about 20 years ago. This is our 20th anniversary, with a goal to make the world, as in process plants, a safer place. So we developed the world's leading certification program for safety system devices. So if you've ever put together a safety instrumented function with SIL rated equipment, chances are it was exida that did that SIL assessment. We also branched out into alarm management and cybersecurity, other areas that impact risk in a plant, to put together products and services to help people achieve their goals there. We have a suite of software focused on safety system design and meeting the requirements of the functional safety lifecycle. As part of that, we also have a tool called SILAlarm, which is an alarm rationalization tool, and we'll talk about that a little bit today. We're going to talk about auditing. Now, what do I mean by auditing? I don't mean the auditing of your finances or your taxes, and I don't mean the auditing step in the alarm management lifecycle or the functional safety lifecycle. What we're going to talk about is the auditing of your alarm system configuration in particular. So the comparison of the alarm settings that you would like to have coming out of alarm rationalization versus those that are actually in the control system and being used at the time. So in terms of the agenda, we're going to look at auditing and enforcement. For auditing, the why, what's the purpose? Why is it important? What can it do for you? The how, in other words, how do you make it work? What are the things to think about? What kind of software programs help? We'll also talk about how management of change works with or against auditing enforcement, how they really go together. And then we'll talk about enforcement, what that does, the different types, different methodologies for enforcement, and how they typically show up in a system architecture. And then we'll look at some examples from industry, some different tools for auditing and enforcement, each of which has different capabilities, different functionality, and different approaches to delivering that capability. So let's start with a mention of the ISA 18.2 and IEC 62682 standards that govern alarm management if you're a process industry plant in any part of the world. Both of those standards define the requirements and recommendations, as well as a workflow process called the alarm management lifecycle. Now you'll notice there is a stage in the alarm management lifecycle called audit. Well, that's not actually what we're going to be talking about. We're talking about the auditing of the alarm system configuration, which actually takes place during the monitoring and assessment stage of the life cycle. So in terms of an alarm management program and when this auditing task actually comes in, if you're familiar with the exida 7-step alarm management program, which starts with some initial benchmarking, creation of an alarm philosophy, alarm rationalization, measure performance, kind of continuous improvement. It's once you get into the rationalization that you now have established something to compare to. So auditing comes on board as a kind of a requirement and a useful thing to do after you've done some significant rationalization and established the requirements for how the system should be configured. So let's look at what the standards require when it comes to auditing and enforcement. So both standards say the same thing. They say unauthorized alarm attribute changes. And when I say alarm attribute, I mean something like the alarm limit or the alarm priority, shall be detected and resolved by comparison of actual alarm attributes against rationalization information. So it's expecting you to compare to the design and the results that were established during rationalization. It also says discrepancies shall be identified and resolved in a timely manner. The target value for unauthorized changes to alarms is 0. And I have underlined the word shall, which shows up twice in this reference, because that means these are requirements. This is something that you must do. So if you are being audited, as in the stage from the alarm management lifecycle, or by your insurance underwriter or whatever, they could check to see whether you are doing this. And if you are not, that would be a violation because you are expected to do this. And the whole purpose really is to help maintain the system integrity of the alarm system. So I mentioned the word alarm attributes. Let's talk about what that really means. So here we have a level control loop that's defined in a control system, and we have a whole bunch of alarm types like high and high alarm and low. For each of those alarms, we have attributes like, is it enabled? What's the trip point or alarm limit? What's the priority? What's the on delay? What's the off delay? What's the deadband? So these are all the alarm attributes that we're talking about in this reference. So if you think about all the potential things that one could audit just for this particular loop, we have some 12 to 15 alarms times 10 attributes. That's quite a lot of things to be concerned about from an auditing point of view. So we're going to talk about that and take that into account when we come up with a recommended auditing program. In fact, we'll consider these different attributes and think about which ones are probably the most important to audit and ones that you should do for sure, and which ones are maybe less important that you may not put as much focus on when doing the audits. So that's what we mean by attributes. Now let's talk about what we mean by rationalization information. So that's, hey, it's the information that we document during rationalization and is typically contained in a master alarm database. The master alarm database is the authorized list of rationalized alarms and their associated attributes. So there's that word again, attributes. So it basically means that the results of rationalization for each alarm, which includes things like priority and set point, which are two attributes that are prime candidates for auditing, along with the other attributes that make up the rest of the design for the alarm, like deadband and on-off delay that we showed on the previous page. It's the combination of those two that are the potential candidates for auditing and enforcement. But one of the key takeaways is that you only have this reference to compare to, generally speaking, if you have performed rationalization and defined all the settings for the alarms. Now, if you're very familiar with ISA 18.2 standards, you may remember that in the 2009 version, there was actually a KPI explicitly for the number of unauthorized alarm attribute changes. And of course, the target was 0. This does not exist anymore in the ISA standard or in the IEC version of the standard. It was actually removed in the IEC standard based on the fact that these unauthorized KPI categories are quite a bit more challenging to determine. You can't just run software and figure out whether something is unauthorized or authorized, as well as it's very different in terms of a category, a different KPI than all these other ones up here, which are true performance measurements or true measures of diagnostics occurring. The unauthorized things relate more to work processes. So these KPIs were removed, so they are no longer in this master KPI table. However, the text and the requirements for what you need to do are still in the standard, and that's what we saw earlier. Now, one of the reasons to do auditing and enforcement is because it can prevent incidents from occurring. I've heard many stories, in fact, 2 of them in just the last week, of some things that happened in a plant. It could have been an unexpected shutdown. It could have been an incident with some damage to equipment that occurred because an operator changed a setting that they shouldn't have, or unbeknownst to them, they shouldn't have changed it, and it led to this kind of an incident. So definitely things can happen if you're not keeping on top of changes that are made to your alarm system that don't go through a formal management of change process. In fact, let's look at an incident that occurred. This was a company that had a safety critical operation. They had an incident occur where the operator should have received an alarm, which would have been the trigger point to tell them that something was wrong and to respond, but they never got it. So ultimately they had a significant incident, and they pursued legal action against their control system supplier, saying there's something wrong with your alarm system. We did not get the alarm that we expected and that we needed under this circumstance. So the control system supplier investigated, and they found that actually the alarm that they were looking for had been active for 12 months already at the time of the incident. So it was already on, and obviously couldn't re-enunciate. And the reason that it was already on and a stale alarm was because the deadband for that alarm was set to 40%. I can't think of any reason or any scenario where setting deadband to 40% would be a good idea. So that was most likely a mistake. Perhaps someone was trying to set it to 4% and, as I would say, fat-fingered the typing and put an extra 0 in there and ended up with 40%. Well, if the company had had a auditing and enforcement program in place that compared the target, which was 4%, let's say, to the actual, which is 40%, it would have identified that discrepancy. And as part of the resolution, one would look and say, oh, whoa, we set the deadband to 40%. That's definitely incorrect or a problem. Let's change it to 4% where it's supposed to be. So if that had been able to be performed, it could have prevented this particular incident. So now let's talk about what alarm attributes should we audit. And here is an example of a DeltaV system where we look at just one typical alarm, and there are 16 different unique attributes for each alarm shown here. And there might actually be a few more within the system that I'm not showing. So how do we figure out which ones are most important, or should we audit all of them? Well, ideally, if you can audit all of them, that would be great. But some of the methodologies for auditing and enforcement require you to kind of prioritize and pick the most important ones. So what are the most important attributes to audit? I would say the ones that directly impact the triggering or the enunciation of the alarm to the operator at the right point in time. So certainly the alarm limit would impact that. The enable disable status would. The alarm priority could impact whether the alarm is shown to the operator or is hidden with other alarms. So that is pretty important as well. But maybe we should add to the list the hysteresis and even the on delay as things that could, if changed incorrectly, impact the enunciation of the alarm at the right time. But the common thinking, the common understanding is typically that the alarm limit, the alarm priority, and the enable disable status are the most important attributes. And those are typically the minimum set that you'll see being audited for each alarm. So how do we get these differences in the system? Well, there's really two different types of differences. There's authorized changes and unauthorized changes. What do we mean by an authorized change, or how could an authorized change occur? Well, authorized implies that you've gone through your management of change process and got review and authorization to make the change. And if the change was made, let's say, by the control system engineer into the configuration based on the MOC, that would be okay. Except if that same change is not made into the master alarm database, then this discrepancy will show up. So that's an example of where a discrepancy does show up, but it's for an authorized change. However, if there was no MOC process initiated, or somebody made a configuration change that they thought would help or did something inadvertently, that's when we end up with unauthorized changes. And for the different roles in the plant, they all have different types and levels of access to the running control system. The control system engineer has access to the actual configuration, for example, while the operator has access to the system through the human machine interface. So whatever access and controllability is provided to them through the HMI gives them the ability. So for example, operators can be set up so that they cannot, by virtue of the security and access within the HMI, that they cannot change alarm limits. So going forward, if you've done rationalization and put in place a thorough MOC process, combine that with setting the appropriate access controls for each role can help minimize the potential for these unauthorized changes. So MOC is what we should go through to make sure that any change is reviewed and authorized. Now, in a well-designed, managed, and maintained alarm system, in the ideal world, there really should be no differences between the control system configuration and the master alarm database. Ideally, any MOC action that's configured in the control system would either be also configured in the master alarm database, or perhaps changed in the master alarm database first and then pushed into the control system. Now, when it comes to management of change, for alarms, we typically look at the type of change and perhaps set up a different level of MOC formality based on the importance of that type of a change. In addition to that, though, we should also think about and pay attention to whether the operator has the ability or the access to be able to change those parameters as well. So as part of the MOC process, I would suggest that you define explicitly by role what parameters can be changed. Because if you make it so that the operator is allowed to change the alarm set point, or I should say is not prevented from doing it, you are much more likely to end up with unauthorized changes, even though the training and understanding might be that the operators are not supposed to do that. In an upset situation, operators might try anything they can to get the system back stable and running. So that could include changing alarm limits when you're not supposed to. So I would recommend considering security and access controls and defining them appropriately to complement your MOC process. So now once you've identified the differences by comparing the rationalized information, which represents the expected values, versus what's in the actual system, your actual values, then you look at those identified discrepancies and investigate them and decide whether you want to accept or reject each one. Sometimes this information is presented right to the operator, which I'm not sure is the appropriate thing to do, since they may not know everything that's needed to be able to make that decision as to whether to accept or reject. In some cases, it makes sense to actually review that stuff offline. But what ultimately ends up happening is the changes that should not have been made will be reset by writing from the master alarm database back into the control system. So that enforcement action can take place automatically, it can take place manually, or it can also be run periodically, like at shift change. I know some end users that brag about their alarm systems and audit and enforcement capabilities and how they run their auditing and enforcement program at the end of every shift to reset the alarm settings back to where they're supposed to be. Well, to me, that's actually kind of scary because it implies that you don't have a very good MOC process. The fact that you need to reset after each operator, to me, is a concern more than a good thing in terms of the functionality delivered. So now when it comes to enforcement, there's two main ways to implement that. There's two main ways to do it. The first is by using an OPC interface, an OPC data access interface. This will read and write to the online system, the running system. And because of that, and because of some costs related to OPC licensing, very often that methodology only does selected parameters or selected attributes, like the limit and the enable disable status and the priority. The second type is leveraging the offline engineering configuration, and that we'll call that a snapshot approach. So it's taking a snapshot of the entire alarm configuration at a point in time, but it's from the offline database. So in terms of how those different methodologies get implemented, here you can see the OPC interface idea, and it needs to have a continuous connection to the running control system because it's reading and writing to your running system, to the alarm settings and statuses. So it needs to have that communication link open and a good set of communication to be able to make that work. The alternative approach, the engineering configuration snapshot, you don't really need to be connected for continuous purposes. You only need to theoretically connect to the engineering workstation to get a snapshot of the alarm configuration on demand when you need it. So you don't really need to be connected all the time, and you wouldn't need any OPC or any need to read to the running system or write to the running system. That would not be necessary because you're working with the offline configuration from the engineering workstation. So those two approaches have some very different pros and cons. The OPC interface, because of communication load and OPC licensing, very often you'll see that involves just looking at selected alarm attributes, the enable, limit, and priority. The engineering configuration snapshot approach really allows you to do all of the alarms and all of the attributes. The OPC interface, because it's reading continuously, almost polling in a round robin approach, it runs at high frequency. So that makes doing these things every shift very, very viable. The engineering configuration snapshot approach takes a little bit more effort to execute. And because it's more thorough and would take more time, that probably is meant to run at a lower frequency, like on a monthly basis. The OPC interface is really connecting with the online running system. So it requires an OPC license to work. You would need to get a license that takes into account the number of alarms times the number of attributes for each alarm. Remember, that could be 10 to 20, depending upon your system. And you need read-write access to the control system. So this will impact your network communication load on your HMI network, and it does open up a significant cybersecurity risk that needs to be handled. The engineering configuration approach doesn't need access to the online running system. There is no OPC licensing required. It's working with the configuration files that come from the alarm system engineering tools. It does not have an impact on the network communication load, and its cybersecurity risk would be characterized as minor compared to the OPC approach. And in this day and age, one thing that Stuxnet virus has taught us is we do need to think and consider cybersecurity when we're performing our analysis to figure out what is the best approach to use. So now we're going to switch gears and look at some examples of auditing and enforcement tools that are used in the process industries. The first one we're going to look at is Exida's SILAlarm tool, which acts both as a master alarm database and an alarm rationalization tool. It follows the engineering configuration snapshot approach. So if we get a snapshot of our control system configuration, all of the alarms, all of the attributes, we load that into SILAlarm. It compares to what's already in the database, and it gives us a readout through our audit viewer of all of the discrepancies that it has found, and then we can review and analyze them and decide what to do. The other benefit of using this type of approach is it can do the auditing on not just inputs from the control system, but for example, if this was a greenfield project where we are incrementally adding alarms or alarm information from, for example, any of these sources, as we do that, we can also be auditing to see whether these are making any changes to existing information, and if they are, that it's the right thing to do. So that's the snapshot approach. And what we see here is the SILAlarm audit viewer interface showing all of the changes that it has detected and providing some context for determining whether they should be accepted, rejected, or enforced. Now it gives us a summary of all the changes that it detected, gives us the ability to globally accept or reject, and to create an enforce file. We're going to look at that in more detail. You also notice that there are different tabs in the view. The one we're looking at right now is for those items that have changed. We'll see also that we can look for additional alarms or alarms that have been deleted. So looking at more detail of what we can do for each alarm discrepancy, we need to ultimately decide whether we want to accept it, whether we want to reject it, or set it for enforcement. Now, you may not be able to make that decision yourself when you first see this. So what SILAlarm allows you to do is to identify who you want to review that change. And then you can keep track of their progress of the auditing of that particular, or the investigation of that particular change. And then you can enter the disposition result in the comment field. So for example, here we found an alarm that had been disabled. So essentially the enabled attribute was changed from true to false. We wanted Thomas Jones to investigate it. He did. It's complete. And what he found was that the operators need additional training. So that's the disposition for that. And we also set that for reject. So that would mean we would not update the master alarm database with that information. But the idea is here we can do a very thorough review of each change, and hopefully you get an idea that this is probably what you should do for any change that you detect. There's a manual process to review each one and decide where it came from and what it means, and whether it should be accepted or rejected, and whether there's not a follow-up action that comes out of it to change the situation that led to that change. So here we're looking at additional alarms, new alarms that were detected and would be added to the database. If you're working with an OPC-driven utility, you may not be able to detect new alarms because you have to tell the utility what alarms to look for explicitly. So you may not be able to detect that. And then we can also detect in the case of alarms that have been removed or deleted, meaning they're in the master alarm database, but they're not in the configuration snapshot that we're looking at as a reference. So this would help us capture that kind of a configuration change as well. Now, because one may not be able to get the audit viewer report and disposition every one right away, every alarm, you might want to pull that information offline and distribute it to other people to look at. You know, maybe the reviewer that you've assigned in it. So we provide the ability to export the audit viewer report to an Excel file that can then be distributed via email. So you could assign what alarm changes you want someone to investigate, and they can do that and enter in the results of their findings, send that file back to you, and then you load that back into SILAlarm, and it will allow you to update the system or set it for enforcement appropriately. So it allows you to do that same review and disposition that you would from the audit viewer. It allows you to do that offline within Excel. And then once we're done, we create an enforce file based on the alarms that we said we wanted to enforce. And that file will then be loaded into the control system. So now let's look at Emerson and their DeltaV system and some of its capabilities. So something that I'll call the best kept secret in alarming in DeltaV is their auditing capability that's built in. It was added in version 13. So they now have the ability to run alarm system configuration audits automatically and behind the scenes. And it will create two different reports, or there are two different audit formats available. The first is called a runtime report, which is really a snapshot of key alarm attribute values at a point in time from the online configuration. The second report is called a differences report. It's essentially a comparison of online versus offline alarm attributes and identification of differences. So for that to work and be meaningful, your offline alarm configuration should truly represent your benchmark, and that would best come after you've done rationalization. But this is kind of a hybrid approach because it operates a little bit like an OPC type approach, but it's also doing some snapshotting and it's not impacting communication performance. So it actually happens behind the scenes in DeltaV. So there's no OPC license needed. There's no impact on CPU loading, and there's no cybersecurity vulnerability because it's the program doing this behind the scenes. The purpose of the runtime report is actually so that you can compare the results to an external master alarm database like SILAlarm. So that's why that audit report format was created, to be able to compare to an external database. So we're going to look in more detail about the different options. So in a DeltaV system with this kind of reporting, and if we were using master alarm database like SILAlarm, there then are really 3 different alarm databases that we need to be mindful of and mindful to keep them in sync. If you are a DeltaV user and you are up to version 13 or later, you could go out after this webinar and set up some difference reports. And as I mentioned, those difference reports do a comparison of online versus offline for selected attributes. And it's the key ones that we mentioned: the alarm limit, the priority, the enable status, and they also add the suppression timeout. So you could do that right away after this webinar is done. If you have SILAlarm, then you can also make use of the runtime report and use that to compare what's in your SILAlarm database, again, for the same subset of alarm attributes. If you want to do a complete audit of all alarms and all alarm attributes, then we use the approach of extracting a snapshot of the alarm configuration via bulk edit and comparing that to the master alarm database. So that's our third option here. So we can actually combine these and create something that's the best of both worlds. We have the option to use the snapshot to get a complete look at all alarms and all attributes. And then we also have the option to run on a high frequency, something that's going to look at our most important alarm parameters, perhaps for our most important alarms. And combining those two gives you pretty good coverage. So let's look at this differences report and what it means or what it shows. So again, that's the comparison of the online value versus the offline. And it's only going to show you information when it detects a difference. So in this case, we have mostly alarm limits changes detected or discrepancies detected. This is the runtime report, which is basically a snapshot of the key alarm attributes that are live and current running in the system for each alarm that you specify. So it includes information like the attributes for priority, whether it's enabled, what its limit is, and also the suppression timeout. And then we can take this file and compare it to what's in SILAlarm as part of our auditing. So if you wanted to set this up in DeltaV, it's pretty easy to do via their system alarm management application. That's where it gets set up. Go through and you launch the reports and define a new report, and you determine whether you want to create a runtime or a differences report, and you define where you want those files to be created and put, and it overwrites each time it runs. Then you set the scope. What alarms do you want to have included? And this is really important because you can get pretty granular in what you're looking at. So you could say, I only want the enabled alarms. You can set it by data source, so only process alarms, or you could look at hardware alarms. And then, most importantly, you set it based on the classification of the alarm. And if you've ever been through one of these webinar presentations with me before, we've talked about alarm class and classification quite often. It's the way to put alarms into kind of buckets where all of the alarms in that bucket have the same sets of requirements for things like training and management of change and testing. So personnel safety alarms is a typical alarm classification. So this means we could set up a report that says, I want to audit only my personnel safety alarms, which are probably some of the most important ones in your plant, and you define that audit and when you want it to run. So we also can set the controller and HMI source, and then we define the frequency for when it runs and the time of day when it is to run. So we've defined the report, defined the scope, now we define the timing, and then that will have the report run when it's supposed to. So here's an example of a whole bunch of reports that are configured to run automatically at a certain time. And you can see the scope can overlap. So if our safety alarms or our personnel safety alarms are our most important, and we say we want that to be audited on a daily basis, that can very easily be done. Maybe we want environmental classification alarms to be done weekly, and then maybe all of the other alarms to be done on a monthly basis. We can also define the runtime reports that would be used for comparison against SILAlarm, and maybe they're set to run monthly, and then in SILAlarm we set it up to pick up these reports automatically and run the audit based on grabbing the report that was created as defined here. So you can really define a set of reports that allow you to get kind of the best of both worlds, the alarm configuration snapshot approach and the higher frequency kind of OPC approach, particularly applied to your most critical alarms. And then in SILAlarm, we can define a scheduler that will automatically grab that report created in DeltaV and import it into SILAlarm and create the same audit report that you would if you did it manually. So you could come in the next day and see the results of your audit, pull that off into Excel, and then send that out for review. Now let's look at the Rockwell PlantPAX system. So it again consists of 3 different databases. If you're using a master alarm database, we have our HMI server, our controller, and then a tool in between called Alarms Builder. So Alarms Builder has the ability to do a comparison of the alarms that are in the HMI server versus in the controller to detect whether there's any new alarms that are set to run in the controller that are not reflected in the HMI server yet. So that would be one auditing path. The other path that we're more concerned about is all of the parameters in the controller for each alarm versus what's in our master alarm database. And here we have, excuse me, again, a hybrid approach with an option on how we finish. But it starts with a snapshot of your engineering configuration from the Rockwell system. That gets loaded into SILAlarm for review and disposition. And once that's been done, you create your enforce file of the alarms that you've said you want to have the changes reset as part of enforcement. And you load that back into the Alarms Builder tool, and now you have a choice. You can either update the offline alarm configuration and download it at the next opportunity, or you can kick off a utility within Alarms Builder that will allow you to read and write via OPC, a very contained application of it, based on the alarm attributes and the alarms that you've identified in the enforcement file. So it will only go and look and read and write to those parameters that you have given it. So you can say, look at what the current value is, and based on that, you can determine whether you want to go forward with the enforcement. And if you do, you can set it to write that value down into the controller. So if you follow that approach for finishing, then the updates as a result of enforcement get done online without needing to do a controller download. So 2 different options on how to finish that one. Now let's look at a Honeywell system and their ACM tool, the Alarm Configuration Manager, which is a piece of functionality that's part of the Dynamo package now, I believe. But again, we're doing a comparison of our rationalized alarms in our master alarm database, which in this case we'll say is the ACM tool, versus the actual running configuration in the Honeywell system. And we're going to end up with a display of the results of the discrepancies for each tag and the type of alarm and indication of what the value was in the master database versus what it is in the DCS. So we've got those reports of the discrepancies, and then when enforcement gets executed, it creates a log and keeps track of that. But in the exception report, and some of the capabilities that you can see here, it's very focused to allow you to review each exception that is detected and decide whether you want to allow the predefined enforcement method, which could be automatic, to proceed, or if you want to override it and have it enforced manually, or say it should not be enforced in this particular case, you can do that from here. So it's concentrated to allow you to really make and look at the decisions on the discrepancies and make a immediate decision whether you want to make that change down into the control system or not. And here we see some of the behind the scenes configuration, some of the global settings, the initial alarm parameters, selecting the alarm parameters that you want to have enforced, so the alarm attributes. And in a more recent version of this tool, they added the capability to do on delay, off delay, and deadband. So it initially was the subset of the most important attributes, like we talked about earlier, the priority, limit, enable status, but then they added the ability to do some additional attributes. And then for each alarm within the configuration, we define for each attribute what type of enforcement action we want to have taken. So M means manual enforcement in this case. So for this particular alarm, changes to priority are to be manually enforced, and same for the alarm limit. They would be manually enforced as well. So you can see the level of configuration and thought that needs to go into the use of that tool. The last one we'll look at is the Yokogawa system. And they have a tool called Exaquantum AMD, so Alarm Master Database. And in this case, we're showing its results when it compares what's in that master alarm database versus what's running in the CAMS system, which is a optional add-on to the Yokogawa system to handle some of the more advanced alarming capabilities. But it is comparing versus the CAMS system, identifying what's different, and then it provides you the ability to manually enforce or to review and accept the automatic enforcement that's programmed into the system. So you can see the differences in how that's assessed. So that kind of brings us to the end of our webinar. So let's talk about some of the key points that we've covered. So auditing is a required task in the alarm management standards. The purpose is really to help you maintain the alarm system integrity, particularly after you've done rationalization. And rationalization is what actually establishes the expected values that you're going to compare to when you do your audit. We saw for each alarm, there could be 10 to 20 different unique attributes that potentially should all be audited. And because of that level of analysis, that leads us to two different approaches to the auditing and enforcement. But in both cases, we're trying to identify the discrepancies, determine whether they're authorized or unauthorized, and then decide if the value needs to be reset in the control system, how that is done, whether it's through the OPC data access interface, which is reading and writing to the online running system, or we're using the offline approach where we're updating the alarm system configuration based on the discrepancies that we've seen. So those are the two different approaches. So auditing and enforcement should complement your management change process, not substitute for it. So what I mean is, when you define your management of change process, that should set up or define what parameters can be changed by the operator, for example, and then you should program the HMI with the associated access and security control, so that if you don't want the operator to make changes to alarm limits or enable disable status, the best way to do that is to eliminate that privilege or that right within the HMI access control. So that goes into the MOC process, and ideally then you're using the MOC process of review and authorization before a change is made. Now, the change might be made in the control system first and then needs to be made in parallel with the master alarm database, or it could be made to the master alarm database first and pushed into the control system. Then you would know, if you did it that way, your systems would always be in sync and you'd never have any audit discrepancies, which in an ideal world should be the case. If you are following a rigorous management of change process and you've set up authorization or access controls, then there should be very little discrepancies that you find during the audit process. Ideally, it would be none. If everything was working the way it should, there would be zero discrepancies. So I want to now just show you some of the upcoming training classes that Exida Academy is offering. So these are our online live training classes. So via the web, led by an instructor, a real live person. You can see the end of November, we have one on alarm management. Continuing through the rest of the holidays, the alarm management one runs again in December. And you can see there's also even some new ones related to automotive and control system cybersecurity as well. So those are our online live training classes. We also have some that are online but on demand. So they're pre-recorded so that you can listen to them and go through them whenever you want and at your own pace. So those are available as well. So if you're interested in learning more about these topics, including alarm management, I'd encourage you to check out those training classes. Also, if you want to learn more about alarm management, we've done many of these webinars in the past, and they're accessible. The recordings are accessible through the Exida website or our Exida YouTube channel. So I hope you've learned something from this webinar. If you have any questions or want to contact us, this is how we can be reached. And then there's my email as well. So now I'm going to just quickly look to see whether there's any questions that can be answered as we are. So there's a question, does DeltaV have built-in alarm reports for these parameters? I think we answered that. That was probably an early question. So, and it looks like that's the only one. If you think of other questions, feel free to enter them into the question box or send them via email. And I'll just at this point say thank you for attending and for your support of Exida and our webinars. And I hope that you'll join us again soon. Take care and have a good rest of the day.